Algebra 2, section 4-4, complex numbers. Complex numbers, we signify an imaginary number with the letter I. And what I is the square root of -1. We've been told that we can't take the square root of a negative number. And so what we do instead is we call it I. And so if I had the square root of -1 times the square root of -1 as in I squared, then I would get -1, right? Just like the square root of 5 is the square root of 5 times the square root of 5, which is the square root of 5 times 5, which is the square root of 25, which equals 5. So that's just a little example of what we're doing here. Now, here is another example of what you might see as imaginary numbers. So you might see 6i, that's an imaginary number, -2i, and I times the square root of -3. So these are all pure imaginary numbers. So let's do some examples on what you might see in the homework. So here is, you are being asked to simplify. Let's do a few of these. So A is going to be the square root of -27. So again, up until now we've said, oh, square root of negative, I can't do that. We're going to do something, we are going to do something with this now. We're going to take the -1 out here, we're going to factor that, and then -1 times 27, and then 27 is 3 times 9, which is 3 times 3, right? And so now I'm going to say this is square root. I'm going to take this 1 out of here, the -1, and I'm going to call that I. And also I've got 2 3's, since this is the square root, I can take out these 2 3's, and then I'm left with 3. So this is the only thing that's going to be left inside my radical. And so we can rewrite this if we want as this -1 times 3 squared, if that's helpful for you to rewrite what we've done here with the factorization. And then we say the square root of -1 is I, the square root of 3 squared is 3, so I've got 3i, the 3 goes after the number here, the constant, and then we still have the square root of 3 left in there. So the 3 squared came out, but the -1 came out here, and then I was left with that 3 all by itself there in the radical. So there's your answer for how to simplify the square root of -27. Let's do another one. The square root of -216. So again, I'm going to pull out a -1, and then I'm left with 216. 216, let's factor this. So that's 2 times 108. And we've got another 2 times 54. 54 is 6 times 9, right? So 6 times 9 is 2 and 3, and 9 is 3 and 3. Okay, so now let's see what we can pull out of this from under this radical. We've got the -1, we've got 2 times 2, this 2 is going to be stuck, and then we got 3 times 3, and this 3 is going to be stuck. So if we wanted to rewrite this, and you can decide if you want to or not, it's going to be -1 times 2 squared times 2 times 3 squared times 3. That's our factorization here. So the 2 and the 3 are going to be left inside, and the 2 squared and the 3 squared, we can take the square root of those. So 2 squared, the square root of 2 squared is 2. The square root of 3 squared is 3. So 2 times 3 is 6. So I'm going to have 6. And then there's my I times the square root of, what's left over here is 2 and 3, which is 6. So 6I square root of 6 is my answer. All right, we're going to do 2 more together because this is kind of weird. C and D, and then I'll have you do a U try. Square root of negative 18. So I'm going to factor this negative 18 as negative 1 times positive 18. 18 is 2 times 9, which is 3 times 3. And instead of writing all of the stuff out, I'm going to say 3 times 3 is 9. The negative 1 is coming out. The 2 is staying in. So I've got 3 times I, right there, times the square root of 2. And my last one, we're going to do together here, square root of negative 125. So 125 is negative 1 times 125. And then I've got 5 times 25. 25 is 5 times 5. So I've got 2 5s. I've got negative 1. 5 gets stuck. And so I have 5 from here. I've got I from here. And I've got the square root of 5 left over. There we go. Let's have you do a couple on your own. Square root of negative 48 and the square root of negative 180. All right, so go ahead and pause right now and do these two, and then we'll, when you're done, we'll unpause and we'll take a look at it together. Go. All right, let's see how you did. I'm going to say negative 1 here times 48, and then 2 times 24, and I'm going to go 4 times 6, 2 times 2, and 2 times 3. And I'm going to circle these 2's and these 2's and this negative 1, and I'm going to underline this 3 to let me know that one gets stuck. The square root of 2 squared times the square root of 2 squared, that's 2 times 2, so I've got 4 that I pull out. And then I for the negative 1, and then the square root of 3. And that should be your answer for that. You try. Now for this one, again, I've got negative 1 that I'm pulling out, 180. I'm going to say 2 times 90, and I'm going to say 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. Got the negative 1 I'm pulling out, I got the 3, and I've got these 2's here, and then the 5 gets stuck. So I've got 2 times 3, which is 6, times I, times the square root of 5. All right, we're going to go on to some more examples here. So I've got negative 5i times 3i. So we're going to multiply these guys together. Negative 5 times 3 is negative 15. I times I is I squared. Now remember, I squared is square root of negative 1 times the square root of negative 1, which is negative 1. So I squared is negative 1. And so negative 1 times 15 is positive 15. Let's do another one. 4i times 3i. See what that equals. All right. 4 times 3 is 12. I times I is I squared. Remember, I squared is negative 1. So 12 times negative 1 is negative 12. Okay. Let's do, oh, I should have had you do that one. All right. We'll keep going. Here's another example. Negative 6 times square root of, the square root of negative 6 times the square root of negative 15. So before we do these ones, let's go ahead and pull the I out. It's going to be helpful if you pull the I out instead of multiplying the negatives by one another. You're going to have some issues. So we're going to say I times the square root of 6 times I times the square root of 15. So pull that negative, the negative 1, the square root of negative 1 out. And then you end up with I squared times the square root of 6 times 15. And the reason I didn't multiply 6 and 15 together is just because I'm going to factor them anyway, so I'd rather not multiply them first. So 6 is 2 times 3, and 15 is 3 times 5. So the 3's can come out, the 2 and the 5 get stuck inside, they get multiplied together. I squared is negative 1, so I've got negative 3 that gets pulled out times the square root of 2 times 5, which is 10. Let's have you do this one. Square root of 20 times the square root of 12. Okay, so remember, take the I out first, and then multiply those together. All right, go ahead and pause and do that you try. Let's see how you did. All right, first, I'm going to pull the I out. Square root, I times the square root of 20 times I times the square root of 12. Now, I'm going to say I times I is I squared times 20 times 12. I'm going to factor these guys. 5 times 4, which is 2 times 2, and 12 times 4, 4 times 3 is 12, 4 is 2 times 2, and we got that 3 left over. So 2's and 2's, 5 and 5 and 3. I squared is negative 1, so I've got negative 2 times 2 is 4, times the square root of 5 times 3, which is 15. 4 times the square root of 15 is your answer for that one. All right, let's keep going. Just moving through this lesson here. Solve. X squared plus 64 equals 0. All right. So I've got, I'm going to subtract 64 from each side to try to get the x by itself. X squared equals negative 64. Now, I need to take the square root of both sides, and I get x equals plus or minus the square root of negative 64. Because this could be positive or negative here, and you would still get this x squared. So we got to do plus or minus. This is important here. So now, let's look at 64. 64 is 8 times 8. Okay, that's great. So that comes out. So I have x equals plus or minus 8. And remember, also I've got the negative 1 there. So 8i. Because I have to take the square root of negative 1, which is imaginary number there. Imaginary number. Plus or minus the square root, plus or minus 8i. Okay, let's do another one together. 4x squared plus 100 equals 0. Subtract 100 from each side. 4x squared equals negative 100. Divide by 4, both sides. X squared equals negative 100 divided by 4 is negative 25. All right, let's take the square root of both sides. X equals plus or minus the square root of negative 25. Negative 25 is negative 1 times 5 times 5. These guys come out, this comes out. X equals 5, plus or minus 5 times the square root of negative 1, which is I. All right, we've done 2 together. You guys do this one. X squared plus 4 equals 0. All right, go ahead and pause and do this one. Go. Let's see how you did. Subtract 4 from both sides. X squared equals negative 4. Take the square root of both sides. I've got x equals plus or minus the square root of negative 4. Negative 4 is negative 1 times 2 times 2. These guys come out. And I've got x equals plus or minus 2, which is the square root of 4, times I, which is the square root of negative 1. All right, let's keep going. We're going to look at complex numbers now. So I've got 2 plus 3i. I've got a real part and I've got an imaginary part. So the real part is this, whatever number this is, and then I have imaginary part that contains an imaginary number. This is a complex number. So let's do an example. We're going to find x and y that makes this true. Okay, so I've got 3x minus 5 plus y minus 3 times I equals 7 plus 6i. Okay, now we need to look at this. We're going to break this up here a little bit so that we can look at it from a different kind of perspective. So we're going to look at this part here as the real part. Notice how there's no I being multiplied by these numbers here. This one is being multiplied by an I. So this here is the imaginary part. Now on the other side of the equal sign, I've got my real part and I've got my imaginary part. So all we're going to do here, we're going to set up two equations. We're going to look at the real parts together, and we're going to look at the imaginary parts together. So let's look at the real parts together. 3x minus 5 equals 7. And all I'm going to do is solve for x, because I'm being asked what are x and y. So I'm going to solve for x here. I'm going to add 5 to each side. And I've got 3x equals 12, divide by 3, x equals 4. All right, that looks good. Now I'm going to do the imaginary part, which is y minus 3 equals 6. I don't need to worry about the I because that's the same on both of these. So I'm going to add 3 to both sides. Y equals 9. And so those are the two numbers, x equals 4, y equals 9, that make this statement true. So that was an example we did together. Now do one on your own. 5x plus 1 plus 3 plus 2y equals 2x minus 2 plus y minus 6 I. So I got a little bit more complicated there, but you should be able to do it just using the same method. So remember, separate it out for yourself however you want to do it. What's the imaginary part and what is the real part? Solve for the variable. All right, pause and go. All right, let's see how you did. I'm going to take my real part and my other real part, and I've got my imaginary part and my other imaginary part. I'm going to just set those equal to each other. So 5x plus 1 equals 2x minus 2. And then my imaginary part is 3 plus 2y equals y minus 6. I'm going to subtract 2x from both sides, and I'm also going to subtract 1 from both sides. The 2x's go away, the 1's go away. Now I've got 3x equals negative 3, divide by 3, x equals negative 1. For this one, I'm going to subtract y from each side. I'm also going to subtract 3 from each side. 3's go away, y's go away. 2y minus 1y is 1y equals negative 6 and negative 3 get me a negative 9. All right, hope you did that all right. We got just a little bit more to go in this lesson. And we're going to do this. Here we go. I've got 5 minus 7i plus 2 plus 4i. And this is a u-try. All I want you to do is use your algebra skills to add these two together. So let's see how you do. Ready, go. All right, welcome back. When I add these two binomials together, I can just ignore the parentheses now because I'm adding them. So this is just 5 minus 7i plus 2 plus 4i. And I'm going to combine like variables, or like terms, I should say. 5 plus 2 is 7, negative 7, and 4 is negative 3. And that is my answer. There you go. You guys are super not being quiet right now. We're going to do another example of something else. I've got 2i over 3 plus 6i times, oh, here's what we're doing, I'm sorry. We're going to talk about the complex conjugate. What we're trying to do here is we're trying to simplify this fraction. We want to get the I out of the denominator. And so the way that we do that is we multiply by the complex conjugate, which is this with a subtraction sign inside of it instead of addition. And if this was negative here, then we would change this to positive. What we're trying to do here is make a difference of squares. What we do to the bottom, we do to the top. So we're just multiplying this thing by 1. So we're going to have an equivalent fraction when we're done anyways. So, but we need to multiply this together. So 2i times 3 is 6i. 2i times 6i, negative 6i is negative. 2 times 6 is 12i squared. Now, underneath, in the denominator, we've got 3 plus 6i times 3 minus 6i. So we could FOIL that out if we wanted to, or if we know how difference of squares works, we know that we're going to end up with 9. We're going to end up with this number squared minus this number squared. So, or this term squared. So 9 minus 6 times 6 is 36. And I times I is I squared. And I squared is negative 1, remember? So I squared is negative 1. So let's simplify this a little bit more. So I've got 6i on the top plus 12, because negative 1 times negative 12 is positive 12. And on the bottom, I've got 9 plus 36. So now I've got 6i plus 12 over 45. Okay, now, we're not quite done yet with this fraction. Because what we do in the book, what we tell, first I need to tell you, we need to write down complex conjugate here. Sorry, I forgot to do that. Conjugate. Okay, now let's keep going. So what we want to do is simplify this even further. And so what we're going to do is we're going to say 6i over 45 plus 12 over 45. So we're going to keep this, we're going to simplify this even farther. And so what we have here is we're going to see what factors are common in both 6 and 45. And the only one is 3. So we're going to divide each of these by 3, and we get 2i over 45 divided by 3 is 15. And we're going to say plus. Did I drop an I somewhere? Oh, there it is. Still there. Okay. Plus, I'm going to see what is a factor in both of these, and again, it's 3. Okay. So I get 4 divided by 3, 12 divided by 3 is 4, 45 divided by 3 is 15. Okay. Now we're almost done. There's one last thing we need to do, and that is the I term, the term containing I needs to go on the right. So I've got 4/15 plus 2 over 15i. And that's how we write this. And I am all done with 4-4. Do a good job on the homework.